Hi everybody and welcome to another theory video, this time looking at something that we call cross-price elasticity of demand. This is the last in our video series looking at elasticity of demand. You've hopefully seen so far 3 videos looking at price elasticity of demand, in other words how changing the price of a good or a service would affect the demand for it. Would it be a significant change or an insignificant change, so inelastic or elastic change? So that was looking at the gradient, so how steep the demand curve was. You've then seen a video on income elasticity of demand, which was looking at how changes in income would affect the demand for a good or a service. And hopefully you remember that a positive number from the formula for YED would show us a normal good, whereas a negative number would show us an inferior good. So normal goods, you earn more, you buy more. You earn less, you buy less. Whereas an inferior good, you earn more, you buy less, or you earn less, you will buy more of it, a negative relationship between the two. Now, cross ED is measuring the responsiveness of demand to the change in the price of another product. So what I'm doing, I'm making the assumption of ceteris paribus again, but the only thing I'm changing now is the price of one product and how that would then impact on the demand of another product. So we've got the formula to work this out, which is the percentage change in the demand for good X divided by the percentage change in the price of good Y. So if we change the price of good Y, how will that affect the demand for good X? Right, now there are 2 main possible outcomes here that we've got to be aware of. The numbers that we get from this formula will show us whether 2 products are substitutes or whether they are complementary products. Okay, so let's think first of all about substitutes. Now remember, substitutes are rival products. They are competing goods and services. So you switch one for another. So for example, we could be looking at Costa Coffee, Starbucks Coffee. We could be looking at an iPhone and a Samsung phone. We could be looking at NatWest against HSBC. You could be looking at 2 rival colleges or schools. Xbox against PlayStation. McDonald's against Burger King, etc. Now, what we would expect to see from the formula if we're dealing with substitute products would be positive numbers. And that is because we'd expect to see a positive relationship between these 2 different products. So, for example, if you were to increase the price of McDonald's, you'd expect more people to go to Burger King instead. If you increase the price of train travel, more people might travel by buses. If you increase the price of an Xbox, more people go and buy a PlayStation instead. So rival products, increasing the price of one would increase the demand for the rival product because people would substitute their demand away from the more expensive product to the other product instead. Now, the bigger the positive number, the stronger the substitutes are. So the more substitutable the products are. Okay, so to give you an example, Nike and Adidas are substitutes. But if people have got strong preference towards Nike, an increase in the price of Nike might not have a significant impact on the demand for Adidas. Many people might view Xbox and PlayStation as weak substitutes. They might have brand preference towards one of them. So an increase in the price of Xbox might, for many people, not shift their demand towards PlayStation instead. A negative number from the formula would show us whether goods are complementary products. Now remember, complements are goods that are bought in joint demand, things that you buy together. Okay, so to give you some examples, if you're going on holiday, you will book a flight and you book a hotel. They're in joint demand. If you go for fish and chips are complementary products, things that people buy together. If I go to the pub for a pint of beer, I might buy a bag of crisps to go with that pint of beer. Goods that are in joint demand. We could be thinking about things such as car and petrol, a games console and a game, a mobile phone and the apps that go on the game. Now, when we're dealing with complementary products, we'd expect to get from the cross ED formula negative numbers. So if you increase the price of one product, it would lower the demand for the other product. If you lower the price of one product, it would raise the demand for the rival product. So to give you some examples, and everyone, if you were to increase the price of a PlayStation games console, that will probably lower the demand for the games. It's a negative relationship between the two. If you lower the price of a printer, it will raise the demand for the ink that goes with that printer. So we've got a negative relationship between complements. So we're going to expect to see negative numbers. Now it's worth noting that the further the number is away from zero, then the stronger the relationship is between those two complementary products. And we'll look at some examples of this in a couple of moments. It's worth noting that a score of 0 would show us unrelated products. Okay, so we're looking here at goods that have got no relationship between them whatsoever. So, for example, if you were to increase the price of tea bags, you would expect it to have no impact at all on the demand for flights to Tenerife. If you were to increase the price of an Xbox games console, it should have no impact on the demand for Coca-Cola. So there'd be no relationship at all between them different products there. So we're mainly dealing here with substitutes and complementary products. Right, hopefully these diagrams here will help you understand this theory a little bit better. So we've got some normal demand curves. What we're dealing with here are double diagrams. Cross-price elasticity of demand is best explained by using these double diagrams. Right, now the first two diagrams on the left are showing substitute products. And I'm dealing here with apples and pears. So if I'm going to the supermarket to pick up a bag of fruit, it will often come down to apples or pears. To me, these are highly substitutable products. So what that should mean, if apples were to become more expensive, I'd switch my demand toward pears instead. If apples became cheaper, I'd buy more apples, and that would lower my demand for pears. Right, now look what I've done in the diagrams then. I've shown the price of apples increasing from P1 to P2. So if apples become more expensive, my demand for apples will contract from Q1 to Q2. What that should then mean is that my demand in the second diagram for pears will shift outwards. At the same price level for pears, I now become more willing and able to buy pears. Okay, so you've got their substitute products, a positive relationship between the two. Apples become more expensive, it would raise the demand for pears. If apples became cheaper, it would lower my demand for pears. The diagrams on the right-hand side show the relationship between cars and petrol. Now, these are clearly going to be complementary products, things that you buy in joint demand. Okay, so I went yesterday with my wife to pick up her new car, and the first thing we did when we drove it was to go to the petrol station to fill it up with petrol. Quite clearly, those two things have to be consumed together. No one's ever bought petrol unless they've got a vehicle they want to put that fuel in. People don't buy cars and don't put petrol in them unless it's an electric car, of course. Right, so anyway, think about what should happen. If I was to increase the price of petrol, then people become less willing and able to buy petrol. There'll be a contraction in demand, so demand will fall from Q1 to Q2 as we raise price from P1 up to P2. Now, because petrol's more expensive, that will then lower the demand for cars. The demand will move inwards. The higher price of petrol will make people less willing and able to buy cars at the original car price of P1. So we've got here a negative relationship between the two. You make petrol more expensive, it will lower the demand for cars. If you were to make petrol cheaper, it would increase the demand for cars. Right, you've got here some numerical examples of this. And you've also got some different diagrams which are designed to show you through diagrams understanding of the strength of the relationship between two different products. Now, in the first diagram, I'm looking at weak complements, and I've identified tea and milk to be weak complements in this example here. Think about why. If you were to increase the price of tea, well, people buy less tea, and that could mean that people buy a little bit less milk, because most people will put milk in the tea as a complement for the tea. But milk has got many other uses. We use it for cooking, we put it on cereal, it's used for baking, all sorts of different things. So you wouldn't expect a strong relationship between tea and milk, but we could test this by building up a really, really simple model. So what I've done here, I've conducted an experiment. I've increased the price of tea from £1.20 a box up to £1.50 per box. So look on that vertical axis in the first diagram. Tea has gone from £1.20 to £1.50. What this will then do is to reduce the demand for milk from 190 to 180. So I'm showing how the change in the price of tea will affect the demand for milk. Now, what you can see is that this curve is very, very steep. There's not a particularly strong relationship between the two. But what we have got, though, is a reduction in the demand for milk caused by that increase in the price of tea. Now, what I could then do is to calculate the percentage changes. Remember, percentage change is calculated by difference divided by original times 100. And if I use that formula, I can calculate that tea prices have increased by 25%. And that has led to the demand for milk falling by 5.2%. Now, what I can then do is to plug those percentage numbers into the cross ED formula. Remember, the percentage change in the demand for good X divided by the percentage change in the price of good Y. So look at this. When I raise the price of tea by 10%, the demand for milk will go down by 5.2%. So in the formula at the bottom of the page, minus 5.2% divided by 25% equals minus 0.208. Now, because it's a minus number, that just proves that these goods are complementary. Remember, negative numbers shows complements, but because the number is close to zero, then we have here weak complements. And that is because the change in the price of tea exceeds the change in the demand for milk. It's an unresponsive change. We've got weak complements. In the next example, I'm looking here at Android phones and apps. Now, to me, these will be stronger complements. These are things that are really, really bought in joint demand. The Android phone, to realize its true potential, you need to download apps for it. But also, you're not going to use apps unless you've got the phone in the first place. So what we've got here is a strong relationship between these two different products. Now look what happens here. I've increased the price of Android phones from £160 to £180. That has led to the demand for the apps falling from 400 to 320. If I calculate the percentage changes, the price of the phones has increased by 12.5%. That has led to the demand for the apps falling by 20%. So if I plug those numbers into the cross ED formula, I've got minus 20% divided by 12.5%, and I get a score of minus 1.6. So we've got here, everyone, strong complements. Okay, the change in the demand for the apps exceeds the change in the price of the phone. But again, I've got a negative number, which will clearly show me complementary goods and services. Right, the two diagrams on the right are looking at substitute products. So the first one, I've got tea and coffee. Now, these are rival products. You know, people do swap tea for coffee or coffee for tea, but many people will have preferences towards either tea or coffee. So my wife, for example, hates tea. So an increase in the price of coffee wouldn't really affect her demand for tea. But there are people like me that do like both. So I view them as stronger substitutes than what she would do. But for most people, tea and coffee will be weak substitutes. They tend to prefer one or the other. But look at the diagram, what I've done. As I increase the price of tea from £1.20 to £1.50, the demand for coffee grows from 200 to 210. So some people are switching away from tea and going towards coffee, but not many people. Now you can see the positive relationship between the two variables this time. Tea becomes more expensive, it raises the demand for coffee. If I work out the percentage changes here, I can see that tea has grown in price by 25%, and that will increase the demand for coffee by 5%. So if I use the cross ED formula again, 5% divided by 25%, I get a score of positive 0.2. So the positive number shows me that we're dealing with substitutes, but because the change in price of tea exceeds the change in demand for coffee, it would show me weak substitutes. The score overall of 0.2 is very close to zero. So we've got weak substitute products here. Now, when we look at the next diagram, Costa and Starbucks, now they both sell coffee. So, you know, coffee drinkers will ultimately probably view Costa and Starbucks as strong rival products. Now, obviously, some people will have preference towards a brand like Costa or Starbucks, but for a lot of people, these two products are highly substitutable. Now, what I've done here, I've increased the price of coffee from £2.40 to £2.70 at Costa. So Costa have increased their prices by 30p. That works out to be a 12.5% increase in price. That then leaves the demand for Starbucks increasing from 200 to 290, and that works out to be a 45% increase in demand. So look what I've got in the cross-ED formula this time. 45% divided by 12.5% equals 3.6. We've got here close or very strong substitutes. The change in the demand for Starbucks exceeds the change in the price of coffee of price of coffee at Costa. So these two are stronger substitute goods and services. Okay, so just to wrap up this slide, everyone. Complement, negative relationship. You raise the price of one good, it will lower the demand for the other product. If you lower the price for them products, it would raise the demand for the other product. Substitutes is a positive relationship. You raise the price of one, the demand for the other one will increase. You lower the price of one, the demand for the other one would fall. So they both increase and decrease together, if you like. Right, now just to take stock of where we are then so far, what I would like you to do, please, is to copy down these questions into your notebooks. Put down your answers. When you are happy, I want you to then carry on watching the rest of the video. So I'd now like you to hit pause, answer these questions, and then when you're comfortable with your answers, click play for the rest of the video, please. Right, everyone, now just to wrap up, I'm not going to go through, by the way, these numerical examples here. I want to go through these in class with you. Okay, so we'll go through these together when we're back in the classroom. All I want you to take out of this is why cross-ED is useful to know for firms. Well, the idea is that if you're selling a product, you've got to be aware that when businesses that are in competition or sell products that complement your products change their prices, it will impact on the demand for your goods and services. So it helps you predict and work out what your demand will be, but also what your revenue will then be as well. So, for example, if you're Costa Coffee and you know that Starbucks are planning on cutting their prices, well, you know that will probably lower the demand for your goods and services. So you've got to plan and prepare for that. You might have to lower prices to match them, or you might have to suffer the consequences of a drop in demand. Pizza Hut, which is located next door to, let's say, the Odeon Cinema in town. You know that people might go to the cinema and then come to your place for a meal straight afterwards. Well, the logic would then therefore be that what you've got to do as a business is to consider the price of going to the cinema. You know that if the cinema becomes more expensive and less people go, that will mean that less people come to Pizza Hut. You need to know that so you can plan and predict for the future. So businesses need to consider how rival businesses and complementary products are changing their prices, because that will have a clear impact on the performance of your business. So really, really important thing for firms to know. Right, I now want you to hit pause and to think about this question. Again, once you are happy with your answer, hit play to watch the last slide of this presentation. Right, everyone, now I just want to bring together all the different concepts of elasticity of demand together into one slide. So we've looked at three different types of elasticity of demand: price, income, and cross. Now what you've got here are the different formulas. What you'll notice is the formulas are all very, very similar. I'm literally changing one variable. So they all have demand at the top of the formula. And then all I do for price, I have price at the bottom of the formula. For income, I have income at the bottom of the formula. And for cross-ED, I will have the change in the price of the other product at the bottom of the formula. Now, when it comes to PED, everyone, what we're looking at here is the shape of the demand curve. So what we're looking at here is how changing the price would impact on the demand. Now, we'd expect to only get negative numbers from this formula, because the basic rule is if price levels increase, demand will contract. If price levels fall, demand will extend. You've got a negative relationship between price and demand. From the formula, if we get a score between 0 and -1, that would signal to us that demand is very price inelastic. In other words, the percentage change in demand is less than the percentage change in price. If we get a score between -1 and -infinity, we've got a price elastic demand. And that means that demand is responsive to a change in price. Okay, so that would mean that the percentage change in demand would exceed the percentage change in price. -1 would show unitary elasticity of demand. And all this means is they change in proportion to each other. So if price goes up by 20%, demand will go down by 20%. PED is useful for firms to know because it helps them decide what they should do with their prices to help them earn more profit. So businesses with a price inelastic demand know they've got to raise prices if they want to make more money. But if demand's elastic, they've got to lower prices if they want to generate more revenue. The middle one, income elasticity of demand. Now, from this formula, we can get either positive or negative numbers. A positive number would show us normal goods. If income increases, demand will grow. If income falls, demand will fall. So we're looking at how much demand shifts and which way it shifts when we change income levels. Okay, now normal goods can be necessities or they can be luxury goods. The idea is if income was to increase, our demand for necessities will grow, but it will be an unresponsive change to that growth in income. Luxury goods, it would be a responsive change to that growth in income. So the percent change in demand would exceed that percent change in income. A negative number for YED would show us inferior goods. So you earn more money, you buy less. You earn less money, you buy more of them. The final one, cross ED. Well, you've got the formula there. And what we know from this formula is that a positive number would show us substitutes. So if you increase the price of one good, it will raise the demand for the other good. So Pepsi becomes more expensive. That should lead to a growth in the demand for Coca-Cola. Negative numbers would show us complementary products. So if I'm thinking about a printer and ink, if a printer was to become more expensive, it would lower the demand for the ink cartridges. So a negative relationship between the two. Remember everyone, a score of 0 would be unrelated products. So for example, increasing the price of aeroplane flights would have no impact on the demand for bottle openers. They're unrelated products. Now, firms want to know both cross-ED and YED numbers for their products for various reasons. Cross-ED means that businesses can predict how, when other businesses change their prices, how it will affect the demand for their goods and services. For YED, as incomes change across the economy, businesses can predict how that income change will impact on the demand for their goods and services. It might dictate what they've got to do. Do they expand? Have they got to make their business smaller? Have they got to maybe change prices to respond to that as well? So PED, YED and cross-ED, everyone, are really, really useful tools for businesses that want to earn more profit. Okay, thank you very much, everyone. We'll stop there.